All right, so now, again, in our mind, we have this layer of plant matter, right, which mostly plant material, but plants have all sorts of different things in them. And we get to bring in our old friends, heat and pressure. So essentially, as that coal layer gets buried, all of the volatiles and the other components of plants, and by other I mean other than carbon, looking back here, so there's water in there that will turn into water. It's not water yet. If you remember H2O, right? Everyone knows that. As this pressure and heat continues, basically water is driven off of these layers, and the remaining, or the residue percent of carbon starts to climb. And so that kind of gradation of heat and pressure is, first of all, what forms coal, but what you also might be able to think about is that means that there's a huge range in what we would call grade of coal, right? So there's some coal that didn't get squished all that much. There's some coal that really gets squished. So this is actually a great diagram. We'll look at it in a separate way here in a second. That shows you, in a kind of stylistic way, how we would see these particular coal grades. And so these are some names that will come up over and over again. These are the general types of coal that we think about. You can see up here in the top, this is a type of coal that's soft brown coal. We call it peat. It's basically like fibrous plant material. Think of peat moss, right? Peat moss comes out of a peat mine. It's the same stuff. Compress it a little bit. It will burn, but it's a really high percentage of all of these other volatiles. It will still burn. It has lots of other volatiles and things in it. It's about 20% carbon. If you're a really big fan of scotch, right, you might like peat smoked scotch. And that should maybe tell you it's really smoky. There's all kinds of stuff that comes off of it, meaning it does not burn very clean. And again, you can see here it looks just like you would guess. So we bury this a little bit deeper. We drive off more water, and we get to the next type of coal that we call lignite. And it's still fairly brown, although it can kind of vary from black to brown. Lignite is that very special kind of coal that's also present as the semi-precious gem jet that you read about. But lignite is in the kind of 20 to 40% carbon, burns a little bit cleaner, is a little more compact. Remember, more water has been driven off and the percentage of carbon is starting to climb. Then we get down into, there's both kind of subbituminous and bituminous coal. I'm just going to lump those two together. This is the type of coal that we use for power. It's been buried sufficiently, a lot of the water has been driven off, and we're starting to get into the 60% carbon, maybe even a little bit higher, 60, 70% carbon. And again, this is the most common type of coal. Now, beyond that, we get into what we call anthracite coal. And anthracite coal is essentially a metamorphic rock. It's been so heated and so squished, and so much water has been driven out. It's in the 90+ % for carbon, meaning anthracite would burn really clean. One of the things that we're going to have to loop back and see in some subsequent videos is that carbon is the compound that will burn, right? And so if we're burning peat, which is 20% carbon, that means that some percent of the volatiles will be driven off as smoke, but there's a huge amount left behind, and that's what we call coal ash, right? So peat, the percentage that actually combusts is fairly small, and you're left with a lot of material, a lot of ash behind. Anthracite, on the other hand, is in the mid-90s percentage-wise for carbon, meaning it produces the smallest amount of coal ash. The biggest problem with anthracite is that there actually isn't very much of it. So if we could just mine anthracite, we totally would. But our the global coal reserves generally haven't been exposed to heats and pressures great enough to drive off that much water. So like I said, the most common type of coal that we use, that we mine, is in the subbituminous to bituminous range. So here, this is a diagram, and it doesn't explicitly say what it's showing, but it also indicates compaction, right? So you may have a thick layer of peat, as shown as this is kind of the dissected version of that previous diagram. As this gets converted to a higher percentage of carbon, that layer actually gets thinner and thinner and thinner, right? So there's a lot of organic material and mass that went into it in the first place, and by the time you get down to bituminous coal or even anthracite, it's a kind of a remnant of that volume. This diagram is much more sterile. It's not these like cool drawings of coal, but it allows you to see some of the things that I've been talking about, right? So if you look at the grades, as you can see over in the left-hand column, peat being at the top, anthracite being at the bottom. Then if you look over in the kind of further right, you can see the percentage of carbon and the percentage of water, right? So that water starts to get driven out as the pressures and temperatures increase. So the moral of the story is coal comes in different flavors, but it really is kind of a gradation, right? So ranging from peat, which is soft, super high volatile, super high water content, all the way down to anthracite. And again, if we could just burn anthracite to supply our power, we would, but there's just not very much of it. Thinking about this proliferation of forests without things to consume the cellulose, that should kind of point out in your mind that that kind of means that most of our coal deposits should actually kind of be relatively the same age. So there definitely are still places on Earth where we get anoxic environments that can still form coal, but it's not as widespread as it used to be. And so actually you can see here, this is an image that shows us the age of coal deposits. And notice there's a really big spike at about 310 million years. So most of our coal deposits are from that short period of geologic time when the forests were everywhere. Soon after, some critters were evolving that could decompose cellulose more effectively, and so we don't see those conditions kind of persisting throughout geologic time. So actually the reason why we call that chunk of time the Carboniferous is because it's really globally marked by coal deposits.